How to determine whether a compound is ionic, covalent, or dative. As we all know, we have two major bonds. We have hydrogen bonding, but I am saying we have two major, which is ionic bonding and covalent bonding. I have intentionally left dative out because dative or coordinate bonding is a type of covalent bond. Therefore, this one depends on this. So how will you tell that a compound is ionic, a compound is covalent, a compound has got dative bonding? Very good. So I want to start with ionic compounds. For ionic compounds, they have what we call ionic bond between them. So when you see a compound formed by a metal and a non-metal, that one is ionic bond. E.g., sodium chloride, magnesium chloride, or magnesium oxide, etc. So I will tell that this one is an ionic compound, because it is a compound formed between a metal and a non-metal, a metal and a non-metal, a metal and a non-metal, and so many examples. So when you see a compound which is formed by a metal and a non-metal, that one automatically is ionic bond. So ionic bond, they have giant ionic structures. So the structures formed by ionic compounds is called giant ionic structures. Very important to know. So if you have identified that this compound is ionic bond, contains ionic bonding, you should know the structure they form. The structures are called giant ionic structure. So covalent, this is a bond formed compounds formed by non-metals only. So when two non-metals combine, like hydrogen plus hydrogen, we form hydrogen. This is a compound. Chlorine plus chlorine will form chloride. This one will form this one. That is a covalent bond. Hydrogen plus oxygen, it will form water. A non-metal, covalent. There's covalent bonding there. So that's how you know. If you see a compound that is between a non-metal and a non-metal, that one is definitely covalent. So let us talk about dative. Dative is also called coordinate bonding. Coordinate bonding. Like we defined, coordinate bonding or dative bonding is a type of covalent. So if it is a type, this one is a type of covalent bonding. So if it is a type of covalent bond, so it is a bond between a non-metal and a non-metal. So you should also know, but what is now the difference? The difference comes when there is, for example, when you have this, a positive. So when you see a compound which has a charge, especially positive and not negative, positive, you should know that this one will undergo dative. right? Because it is an animetal hydrogen, oxygen is an animetal. Once you see positive, you should know that that one is a dative dative bonding. So this one is called hydroxonium ion. We have another one, ammonium ion. When you see this one, you should know that this one will undergo dative. Another example which you need to know that doesn't have the sign, the positive, which will show you that it is dative, is CO, carbon 2. Carbon 2 undergoes dative bonding. Carbon 2 undergoes dative bonding. Therefore, you should know that carbon 2 oxide undergoes the coordinate bonding. Substance or compounds which have covalent bonding, they form structures. Those structures, we have those that are simple molecular structures. For example, hydrogen, this one will form a simple molecular structure. S sulfur plus oxygen will form SO2. This one will call it simple molecular structures. But there is a difference when carbon combines with oxygen to form CO2 and silicon combines with oxygen to form silicon 4 oxide. So this one, they don't form simple molecular structure, but they form giant. Of course, it is covalent bonding, but they form giant covalent bonds. Structures. They form giant covalent structure. Why? You should know what the relationship between these. Silicon can lose 4 electrons to be stable. Silicon can gain 4 electrons to be stable, similar to carbon. Therefore, that's where the difference comes in. Thank you for your time. Comment if you have any question.